Okay, good morning class. Alright, today we continue, okay, for the last subtopic, okay, for chapter 4, okay. There is a extraction of metals, okay. And after this, I will assign you a work in GC, right? So all of you have to answer that one, okay? It's a compulsory. That one is actually the checkpoint, okay? So that one, the quiz is actually used for your exercise for Teams and PISA. So all of you must answer the question, okay? And one more thing, right? You have to use my email, okay? So I will send my email, okay, in the class group, okay? So you have to log in with using my email, okay, because I need your mark, okay, for record, okay. So this is the link. I will forward the link and also my email in the group. So later when we finish the class, you can go and answer the question. And also I will assign in GC too. So let's say if any problem, you can text me, okay. So let's continue. Okay, so our next lesson. So extraction of metals from their ores. Okay, so the first one, the application of reactivity series of metals. So what is the function that we learn reactive series of metals? So the first one is actually to get the metals, because you know that mostly metal that exists in a compound. Okay, so if you want to get, let's say, aluminium oxide, you have to extract the aluminium from the you have to extract the aluminium first, so you can get the metal. Okay, so that's the function of the reactivity series. Okay, so you can extract the metal that you want, okay, from the compound. So most metal in the earth crust are in compounds form. Okay, means it's not in the element form like silver or like gold. Okay, so that one is they already exist in elements, so you just can straight away take it. Okay, but let's say for the aluminium, for the bioxide. Okay, for the bioxide, they are from aluminium and aluminium oxide. So mean you have to extract the aluminium from the aluminium oxide to get the aluminium. Okay, so and then the next one, so the example, so this is the example. So let's say iron oxide. So the ore is called as a hematic, right? So the metal that you want is iron, okay, and aluminium oxide is a bioxide, okay. If you want the metal, so that one is aluminium, okay, and the composition is the aluminium and oxygen, okay, and tin is a cassiterite, so that one is a tin oxide. So if you want you want to extract the tin, okay, from the tin oxide, okay, and then another one is a sphalerite, okay. So that one is a zinc sulfide. If you want to extract zinc from the zinc sulfide, okay. So ores are separated from impurities by physical separation, followed by the extraction of metals from the ores. Okay. So before we extract, we have to do the physical separation first. Okay, to extract from impurities. Okay. Okay, extraction of metals. So what is the process of the extraction of metals? Okay, that is to process to obtain metals from the ore. So just now, like I giving you the example, aluminium oxide. So mean you have to extract the aluminium from the aluminium oxide, right? So that is the process of the extraction of metals. Okay, extraction of metals can be carried out by two methods. So there are two ways for you to extract the metals. Okay, the first one we call it as the electrolysis. So this one is actually you already learned, if I'm not mistaken, in form 2, right? Chapter 5, okay? Water, right? Water and solution, okay? The one that you have to extract the water, okay, to form the hydrogen and oxygen, okay? And can produce the gas of hydrogen and oxygen. And you have to connect the circuit, okay. I have to use the electricity, okay, to do the electrolysis. Okay, so the electrolysis of molten ore of metals for reactive metal which are more reactive than carbon. So I'm sure you already know the reactive series: calcium, potassium, sodium, right? Calcium, magnesium, aluminium, okay? So carbon, zinc, okay? So for those who are like upper part than carbon, they have to use, they are more reactive than carbon, they have to use the electrolysis. So I'm giving you an example like this. So this is the reactivity series of metal. So let's say natrium, okay, calcium, magnesium, aluminium, okay, and then carbon, zinc, um, okay, so until here, so for this part, they have to use the electrolysis, okay. So because they are more reactive than carbon. So below here, okay, they have to use the process of the, by using the blast furnace, okay. This one we use the process of reduction, okay, reduction by carbon, okay, because this one the carbon is more reactive, so they can use the carbon, okay, to extract, okay, the metal that below than the carbon, okay, means more or less reactive than the carbon, okay. For more reactive than carbon, then we use the process of electrolysis, okay. So the reduction of metal ore using the carbon, okay, for less reactive metal which are less reactive than carbon. Okay, so this is the empty series of metal. So you can see, okay, at the upper part here, okay, calcium, nitrogen, calcium, magnesium, aluminium. So for this part, because they are more reactive than carbon, they will use the electrolysis. Okay, for those who are like less reactive than carbon, like zinc, hydrogen, ferrum, okay, and then tin, okay, stannum, plumber, copper, mercury, antimercury only. So this one, they can be extracted by the carbon, okay, until from zinc to plumbum, they can extract by carbon. Okay, for copper and mercury, because they are very less reactive, so we can just heat the oil on in the air. So let's say if cuprum oxide, we just heat up the copper in the oxygen, okay, then we produce the copper. Okay, so for this one, we just need to heat up, right? So let's say if I have a copper oxide, okay, so I just heat up, they will produce a copper and oxygen. Okay, so then don't need to use the carbon. Alright, for carbon only from zinc until plumber. For this one, because they are very less reactive, so we just need to heat up in the oxygen, they can produce the metal already. Okay, but for this one, they exist in element, right? So means you don't need to extract them. Okay, because they already exist in element. Okay, so you need to remember, for those who are more reactive than carbon, then we use the electrolysis. Okay, for those who are less reactive than carbon, okay, until plumbum, then we use the reduction process, okay, by using the carbon, okay, and copper and also mercury, because this one very less reactive, so we just burn it in the oxygen, okay, then we produce the metal already. Okay, they can just eliminate the oxygen, okay. And for those who like silver or gold, yeah, that one is actually on elements, so you don't need to extract them anymore. Okay, so let's see the extraction of metals from the ore. So they use a component, we call it as a blast furnace, okay. So tin ore is mined and washed to remove impurity by flotation process. Okay, so before we use the carbon, okay, we have to wash, okay, and also we have to remove the impurities, okay, by the flotation process. So the flotation process means the one that floating is actually the less density, right? So then we remove that one, okay. So to remove impurities by flotation process, so first you have to wash first, okay, and then the second one, the tin ore is heated to remove sulfur and arsenic in it. Okay, so before we use the carbon, we have to heat the tin ore, okay, to remove the sulfur and also arsenic. Okay, and the next one, the tin ore is then mixed with coke. Okay, so coke is actually a carbon, and a limestone at 1300 degrees Celsius to 1400 degrees Celsius in the blast furnace. So the first one you have to wash first to remove the impurities. Okay, and then the second one you have to heat first. Okay, heat the ore first to remove sulfur and arsenic. And the third one you have to mix the tin ore with the calcium carbonate and also the coke. Okay, limestone is actually the calcium carbonate. Okay, same thing. Okay, so carbon remove oxygen. So there are two parts of the reaction here. Okay, the first part, the carbon from the coke. Okay, we remove the oxygen from the ore. Okay, the carbon from the coke here, we remove the carbon from the coke here, we remove the oxygen from the ore. Okay, so means tin ore is tin oxide. So you remove the oxygen from the tin oxide. Okay, and then the limestone is react to impurities in the tin ore to form slag. Okay, so the first one is to produce the tin, and the second one is to produce the slag. Okay, so there are two kind of process here. So the first one is to produce the tin, the second one is to produce the slag. Okay, so the molten tin and the molten slag, okay, will flow to the bottom of the furnace. Okay, so the slag float on molten tin and the bolts are removed through and out the pipe. So the slag will be on the top. Okay, it will move to on the right side, and for the molten tin, they will remove to the left side. Okay, so the slag is actually on the upper pipe. Okay, and the molten tin is the below one. Okay, so we see the process one by one later. Okay, the molten tea is flowed into mold and left hardened and cool as ingots. Okay, as ingots. Okay, extraction motor. Okay, so this is the blast furnace. Okay, so the process, the first one I already told you, you have to wash first. Okay, you have to wash first the tin ore to remove the impurities. Then you have to react, okay, to remove the fast phosphorus. Okay, and the third one, then you have to mix the coke, okay, the calcium carbonate, and so the iron ore. Okay, so the first part is mixture of concentrated iron ore, okay, or iron oxide, we call it. Iron ore, iron oxide, and coke. Coke is a carbon here, okay, and limestone. Okay, so we add this mixture into the blast furnace, okay, through the top. Okay, and then the second one, okay, you put the very hot air, okay, inside of the blast furnace, okay, at the bottom of it. Okay, so a very hot blast of air is pumped into the furnace through the bottom. Okay, so you put the hot air at the bottom of it, also let it flow inside the blast furnace. Okay, and then the third one, okay, the reaction in production of iron and slag occurs in the furnace at higher temperature. Okay, so after you put the hot air here, the carbon, the mixture here will be burnt. Okay, so the reaction in production of iron slag occur in the furnace at high temperature. Okay, so this one we will discuss more further after this. Okay, and number 4, iron and slag that is produced will melt at higher temperature in the furnace. So you can see at the upper part here, this is the slag. They will go to on this side, while the molten iron will go at this side. Okay, so the upper part is the slag here. Okay, so the production of iron. So we will see one by one. How does you produce the iron? So you have to remember in the blast furnace, they will produce two types. Okay, the first one is produce iron. The second one is to produce the slag. Okay, so let's see the production of iron first. Okay, so the production of iron, coke or carbon. Okay, coke or carbon react with oxygen in the hot air. So the hot air is come out from the bottom of it, right? So the coke and the carbon react with oxygen in the hot air to produce the carbon dioxide and heat. Okay, the carbon mixed with the oxygen in the hot air produce carbon dioxide. Okay, and then the next part is the carbon dioxide that is produced, okay, by the mixture of the carbon and the oxygen. Okay, the carbon come from the coke. So the carbon dioxide that is produced react with the rest of the hot coke to form a carbon monoxide, which is a strong reducing agent. Okay, so this carbon dioxide, okay, there's still some coke, okay, inside the, there's still some carbon, okay, inside the coke, right, okay, which that is still not react, okay. So the carbon dioxide will react with the rest of the hot coke there, okay, to form the carbon monoxide. So the carbon dioxide just now that produced, carbon come from the coke, mixed with the oxygen from the hot air, produce carbon dioxide. Then this carbon dioxide will react again, okay, with the carbon from the coke, okay, to produce the carbon monoxide. So the carbon monoxide is a very strong reducing agent. So this is the important part you need to remember. So this carbon dioxide is a strong reducing agent. So strong reducing agent means it will take the oxygen from the tin ore, okay, to, so it can only leave the tin there. So it will take the oxygen from the tin oxide. So after that it will be left, okay, only tin there. Okay, so let's see the equation. So the carbon monoxide and carbon reduce the iron oxide into iron. So this is what I said just now. Okay, so you can see the iron oxide, okay, the iron oxide, when it react with the carbon monoxide, okay, so it will take the oxygen from the iron oxide to produce the carbon dioxide here, okay, and it produce iron. It will just leave iron. Okay, and also for carbon, okay, they will react carbon, iron dioxide will produce the, will react with carbon to produce the iron and carbon dioxide. Okay, and for iron oxide, we react with the carbon monoxide to produce iron and also carbon dioxide. So this carbon monoxide is a very strong reducing agent if you compare with carbon. Carbon also is a reducing agent. Okay, but okay, if you compare carbon and carbon monoxide is a stronger than the carbon, okay, for reducing agent. Okay, so carbon monoxide combined with the oxide, iron oxide, to produce iron and carbon dioxide. Okay, so remember these three steps. The first, carbon from the coke react with the oxygen in the hot air to produce the carbon dioxide. Okay, and then this carbon dioxide will react with the rest of the coke that still not react with the oxygen. Okay, so it will produce the carbon monoxide here. Okay, this carbon dioxide react with the carbon. So where's the carbon come from? From the coke that still not react with the carbon dioxide. So it react, it produce the carbon monoxide. Okay, so this carbon monoxide is a strong reducing agent. Okay, so the iron oxide will react with the carbon monoxide. Okay, when I said reducing agent means it will take away the oxygen here. Okay, and it will just leave the iron. Okay, so that is called a reducing. It reduce, right? So before this, it consists iron and oxygen. So reduce means it become less. So until become only iron. Okay, so that is the reason. And carbon also is actually the reducing agent, but it is not strong as the carbon monoxide here. Okay, so this is the how we produce the iron. Okay, the next part is the production of slab. So remember I said in the blast furnace, we just don't produce the iron. Okay, we also produce the slab. Okay, so the slab is come from the limestone of the calcium carbonate. So remember just now, okay, when we add the mixture, right, inside the blast furnace, we add the calcium carbonate, okay, we add the tin ore and we add the carbon, okay, and we mix them together. So here is the function of the calcium carbonate. So the calcium carbonate is used to produce the slab. Okay, so the limestone or the calcium carbonate decompose to form the calcium oxide and also carbon dioxide. So this is the equation. Calcium carbonate, okay, calcium carbonate, okay, when it heated, it become calcium oxide and carbon dioxide. Okay, and then the calcium oxide here that produce, okay, all right, will react with the impurities such as sand or silicon dioxide in iron ore to form a slab. Okay, so means when the reaction occur, okay, inside the iron ore is not only like iron and oxygen. So there's still another element inside the iron ore. So we need to remove, okay, all the impurities there so we can get only iron. So actually the calcium carbonate here is for what? It's actually to take away all the impurities. So it will be left only by iron. Okay, so this calcium hydroxide will react with the impurities, okay, such as sand and silicon dioxide in iron ore. So if we take away, we take the sand and silicon dioxide in the iron ore, so then it will form the iron only. Okay, so to form a slug here. Okay, so this is the equation: calcium oxide plus silicon dioxide, you produce calcium silicate. Right, so this is the function of the calcium carbonate. It's actually to remove the impurities, okay, from the iron ore, so then we can get only iron here. Okay, so the function of the slug here is can be used for the base of the building, okay, or road. Okay, so this is the function of the slug. Okay, so remember blast furnace produce two substance. The first one is iron, the second one is the slug. The iron is actually, I already explained how does it react, okay, and the slug is actually from the calcium carbonate. Okay, that one is actually the function is to remove the impurities, okay, from the iron ore, so we can get only iron there. Okay, and it will produce the calcium silicate. Okay, calcium silicate. This is the video. Yeah, to 200 Kelvin. You don't need to remember the equation here. What you need to remember, the one that I give you. Okay, in the words, the carbon plus oxygen will become carbon dioxide. Carbon dioxide then react with the carbon will reproduce the carbon monoxide. Okay, this one is actually the higher levels. Right, so that's the video. Okay, so mining issues in Malaysia. So usage of the large amount of electrical energy, okay, and air pollution. Okay, since because it will release the carbon dioxide, okay, and it will produce a smoke, okay, a lot of smoke of it, from it. So it will cause, okay, air pollution, right? And then the water pollution due to cleaning the ore. Okay, because I remember just now the first step that we have to do is we have to wash the iron ore first, right? And then we have to remove the impurities by the flotation process, right? So the flotation process they require a lot of water, and then after that the water will be released. Okay, so that we calls the water pollution. Okay, and then the sound pollution, of course, okay, from the blast furnace is very noisy. Okay, and the air pollution due to burning of fuels. Okay, and the soil erosion due to the mining of ore. Okay, because you know the ore is actually inside the earth crust, right? So we need to drill, right? To drill. Okay, so you can get the iron oxide. Okay, and then the destruction of habitat due to the construction of mines. Okay, so this is the mining issues in Malaysia. Okay, so what is the importance of the reactive series? So what we learned, so reactive series of metal are arranged according to their reactivity with oxygen. So remember, the reactive series of metal is actually the construct, okay? It construct by the reactivity by oxygen. Okay, how does each metal react with the oxygen? So the more the react means it will be on the top of the list, right? So actually it based on the reactivity with oxygen. So the more they react with the oxygen, that means they are more reactive. Okay, so reactivity series based on the reactivity with oxygen. Okay, so the importance, okay, to forecast the reactivity of particular metal and able to decide the method of storing the metal. Okay, like now, just now, if you want like iron, right? Okay, so you know there's a lot of function. Okay, by using iron, the one we make a can. Okay, they use a tin. Okay, so we need if we know the reactive series. Okay, so we know what kind of method that we need to use, so we can extract the iron from the compound. Okay, so to predict whether reaction will take place between a metal with an oxide of another metal, so where we can decide whether this metal can react, okay, or not with another metal. Okay, and then another one to determine the method of extraction of certain metal from its ore. This one we already discussed just now. Okay, so we already finished chapter 4. Okay, I'm not sure whether the school will still open. Okay, after the school holiday. Okay, and then if open, then we continue on chapter 5. If not, then I will just continue. If we can do experiment first before I continue. If the school open. Okay, if the school still closed, then I will just continue with chapter 5. Okay, so I will stop now. Okay, but I remember, please answer the link that I give. It's a compulsory. Okay, after this, we still have a more checkpoint to answer. This one is actually for your teams and PISA. Okay, so please answer it. Alright, I will send the link through GC and also through the class group. And make sure you use my email so I can record your mark. Okay. So thank you class. Okay, and thank you for attending class. Alright, so my sorry, I didn't notice your extraction of metal happens for all kind of metal or only metals from start from copper. It can you can extract the metal. Okay, you can extract the metal with that means from calcium. So let's say you want to extract for calcium, right? So you need a certain way. You can extract all the metals, but each metal they need to extract in certain way. Like calcium until I think aluminium, they need to use the electrolysis process to extract. Okay, and then they say from carbon, okay, carbon anti-plumbum, right? So if you want to extract the metal, you need to use the process of reduction, right? You use the carbon. And they say the copper and also the mercury, that one is a very less reactive. You can just burn in the oxygen, you already get the metal. Okay, and for the silver and the gold, that one is an element, so you don't need to extract it. Is it okay, Pavindip? Pavandip, sorry. Teacher, the function of coal is to produce carbon. Yes, coal is actually carbon. The other name for coal is actually carbon. Okay, so any other question? I'm sorry because I didn't notice your text. Okay, alright. So remember, make sure you answer the checkpoint here. I will assign in the GC and also in the group. Okay, so have a nice holiday, school holiday. Okay, take care. Alright, bye class. Welcome.